Hey, welcome back. So now let me create a new project. Let me just quickly select the board and let me call the project name as HSI measurement, and here I'm going to select empty, finish. So let me close this. So great. So what I'm going to do now is I'm going to my earlier program and I'm going to copy this code because some of the code we are going to reuse. So I'm going to paste here and I'm going to remove all these ADC stuffs here. Let me remove that, and so let me remove all these things. So first of all, we need this RCC base register. So our first step would be configure the RCC CFGR register. Right, so here we have to touch the bit position 21 and 22. We have to configure this. Let's do that. First, let's calculate the address of this register. Its offset is 0x08. Here, let's change this RCC CFGR reg offset. So this is 0x08. So RCC CFGR reg ADDR. So RCC base address plus this one, isn't it? Let's change this. After that, let's create one pointer variable to hold this address. So I'm going to write uint32_t star p RCC CFGR reg is equal to, let's initialize this pointer variable with this address. Let's make it as an address. So after that, we have to configure these bit positions as zeros, isn't it? Let's do that. So we have to clear these two bit positions. Let's do that. So now let's dereference this pointer and is equal to negation of 0x3 shifted by 21. So here clear 21st and 22nd bit positions. So this is basically configure the RCC CFGR MC01 bit fields to select HSI as clock source. So now let's go to the second step. The second step is configure PA8 to AF0 mode to behave as MC01 signal. So if you set the mode for this pin as AF0, then this pin will behave as MC01 signal. And for that, you have to do some configurations for the GPIO-A peripheral. Why? Because PA8 belongs to GPIO-A peripheral. So here I have written some code, and you are not expected to understand the below codes for the time being. So because these codes are related to GPIO configurations, and GPIO configurations will be covered in later sections of this course. But I will briefly explain you what's happening here. The first step, what you should do in step 2 is enable the peripheral clock for GPIO-A peripheral. That is very important because we are going to now change some configurations for the GPIO-A registers. So as I said before feeding any configuration values to the peripheral, you must enable its peripheral clock. And we also know that GPIO-A is connected to the AHB1 bus, isn't it? So that's why I'm first creating a pointer variable here to store the address of the AHB1 ENR. So I can get the AHB1 ENR address by adding the offset 0x30 to the RCC base address. And after that, I am enabling the clock for the GPIO-A peripheral. So I have to set 0th bit as 1. If you are not sure about that, let me show you once again. So here it is, RCC AHB1 ENR. So let's open that, RCC AHB1 ENR, so which is at the offset 30, and here GPIO-A is 0th bit. So I'm setting this bit. And after that, step B is configure the mode of GPIO-A pin number 8 as alternate function mode. So this is something to do with alternate function mode, and as I said, we'll discuss more on that later. And this is how I'm doing that. So this actually sets the alternate function mode for this pin. And for that, I'm going to access the GPIO mode register from the GPIO register sets. And after that, the step C is configure the alternate function register to set the mode 0 to PA8. And this is how I do it. Actually, I do it using the alternate function register of GPIO peripheral. I can access that register by adding the offset 0 cross 24 to the base address of the GPIO A peripheral registers. So if you are not understanding all these codes, then it is perfectly normal. Don't worry about that. So just follow the lecture, and in later lectures you will become master of all these codes. So don't worry about that. Now let's test this code. Let's see whether we are able to observe 16 megahertz of HSI clock on the pin PA8. So PA8 pin you can find on expansion header of the board. So now let me open the picture of this board. So here it is. You can get PA8 here. So what you do is, so if you have a logic analyzer or oscilloscope, actually I'm using USB based logic analyzer, which is a low cost signal probing device. If you don't have this, then just watch this video, need not to try anything. But if you have logic analyzer, then you connect the channel 0 of the USB logic analyzer to PA8 pin of the board. And after that, connect the ground point of the logic analyzer to ground point of the board. So on the board, there are a couple of ground points. So you can find 4 ground points. You can use one among these. So now I just connected my SAILI logic analyzer to the PC, and I just opened the software, and you can see that the software detected the hardware, and that's why it is showing connected. And after that, now I also connected channel 0 of the SAILI logic analyzer to PA8 pin on the board. And please note that ground should be properly connected. Let's download this code. So here, let me click apply, OK, switch, and let's debug this code. Here we are clearing the MCO1 bit fields. That's okay. Here we are enabling peripheral clock for GPIO A. Let's proceed. So now let's check whether that is true or not. Let's go to the HB1 ENR, and GPIO A is enabled. Yes, correct. Right. And after that, let's proceed. GPIO mode configuration. Everything would be fine. Let's run the code. Now the code is running on the target, and let's sample. Now we indeed got some clock, but before that, let me tell you that speed, you can configure it as 24 here. That is 24 million samples per second, and duration you can set for 4. And now let's sample, and here it is. We got the clock. Now here we got the clock, but the clock is not 16 megahertz. So that's wrong, isn't it? So it's showing 8 megahertz, which is not true. The reason for this is my hardware. My hardware is very basic one from SAILI. I didn't actually buy the advanced one. Its limitation is up to 8 megahertz. It can sample the signal up to 8 megahertz. If the signal is pretty fast, like 10 megahertz or 16 megahertz, this hardware won't be able to sample it properly. What we can do now is we can do one trick here. So let me go to the project, and let's go to this clock diagram. Let's go to this clock diagram, and here you can see that there is a prescaler, right? And by using this prescaler, we can divide the HSI, right? Let's divide the HSI by 2. Let's use this prescaler. Where to configure this prescaler? Again, in the RCC CFGR register. Let's go to the RCC CFGR register once again, which is right here, and here it is, MCO1 prescaler, right? Let's explore these bit positions. 24, right? So here it is, 24, 25, 26. So it is by default 0. That means no division. So now you make 24th bit as 1. That would divide the HSI by 2. Thereby we'll be getting 8 megahertz of clock, so that our hardware can sample that properly. I mean, if your hardware is sampling 16 megahertz properly, then no problem. You need not to do all these things. So now I'm going to set the 24th bit as 1 to divide HSI by 2. Let's do that. Let me go to my HSI measurement. Let me close this. So I'm going to do that here after this. So configure MCO1 prescaler. So star this pointer or is equal to, because I'm setting 1 shifted by 24, isn't it? That's it. So it's better before that you may clear all these bit fields, so you can always do that. But since it is already 0, I'm just setting this bit to 1. Let's try once again. So I'm going to click this, that is terminate and relaunch. It will compile and relaunch the debugging session. Let's wait. Let me hit run and let's sample. Right. So here you can see that it is now showing 8 megahertz, but the clock is not uniform, isn't it? So still it is not sampling properly. Let me do one thing. So let me again go back to the reference manual and let me divide by 4. So that means make 25th bit position also 1. Let me try that. So 16 divided by 4, I should be seeing 4. Let me make one more statement here and let me make 25 also as 1 and let me try again. So I'm still seeing 8 megahertz. That is absolutely wrong because it must show 4 megahertz, isn't it? There is something wrong with the code definitely, and I found out the mistake. The mistake is in the reference manual. Here it is written incorrectly. It must be 26:24. So please note this change. So that's why to set the division by 4, we have to set 25th and 26th bit as 1. Let's do that change in the code. So 25th and 26th. Let's try again. Let's run. Let's sample. Right, here it is. We are getting the 4 megahertz clock. So the prescaler is 4. Here we are getting 4. So 4 multiplied by 4 gives us 16, isn't it? So that proves that HSI is indeed running with 16 megahertz of clock. So if you are using Discovery Board, then you can definitely try this code at your desk. Code is available on our repository. And if you don't have Discovery Board, or if you are using some other board, then you can try by making some changes to the code. But if you don't succeed in getting this clock, then don't worry at all. So when you complete the GPIO section, we can again come back and modify your code. And with that note, I would like to end this video. I'll see you in the next lecture.